Hello everyone, and welcome to the Best Practice Online session hosted by AtScale and Zaloni, the ideal architecture for BI on big data. I am very pleased to welcome two of today's speakers. We have Scott Gidley with Zaloni and Josh Klahr with AtScale. Zaloni is a leading provider of Hadoop Enterprise data lake management software and solutions. And for those of you who are not as familiar with them or would like to find out more, you can learn more about Zaloni at Zaloni.com. Now, Scott actually represents Zaloni as the Vice President of Product Management. And there he's responsible for leading strategy, roadmap of both existing and future products for their entire portfolio. He's nearly a 20-year veteran that brings a lot of really great experience in the data management software and services market. Prior to joining Zaloni, Scott, I read that you actually also served as a Senior Director of Product Management at SAS and was CTO at Dataflux and received your BS from the University of Pittsburgh in computer science. So go Panthers. Welcome, Scott.
Hey, Irina, great to be here.
Thanks so much. I also have with us today Josh Klahr, who is the Vice President and also a co-founder here at AtScale. Josh's background is a little bit interesting. He has a Bachelor of Science in Material Science, but transitioned into the tech world with his MBA and has been helping organizations with their data management, including helping back at Yahoo when Hadoop was first being incubated, which is where all the founders of AtScale, most of the founders of AtScale, got started diving into BI on Hadoop. And Scott has helped companies like Walmart, Orbitz, Union Bank really dive in and make BI work on Hadoop. And so he's going to be speaking to you as well. My name is Irina Lewis. I'm the Senior Director of Product Marketing, and I'm simply going to be moderating today, helping guide everyone through their session. Today, what we're going to be covering, we're going to start out by talking about the opportunities that our modern data world really represents for us. We run into challenges, but those are also opportunities. Then we're going to walk you through with some proven and experienced strategies on architecting that ideal environment for BI on big data. And we'll actually show you a short demonstration bringing it all to life at the end. Now, before we jump into that and transition over, I have a couple of questions that will help our speakers understand the audience, you that are joining us today. So with that, I've got two questions. I'm going to bring them up on the screen here. One is, what big data distribution do you use today? The results are, it looks like there's a pretty even split between Cloudera and Hortonworks, so this might be interesting, Josh and Scott, for you to have in the back of your head. We've got some people who are just dipping their toe in the water, kind of looking at Hadoop for the first time ever. So thanks for that as well. We have one other question. For those of you who do have Hadoop in place, how many nodes in your cluster? Because it really doesn't matter whether you are just dipping your toe in and starting, or you've got quite a few nodes. We have seen that architecture matters no matter what the size, and in some cases, the sooner you start out architecting for the ideal environment, the better. Okay, let's go ahead and share results. And it looks like a bulk of our attendees today have anywhere between 1 and 100 nodes. So thank you again for sharing that. So with that, we're going to take the first step toward getting you the answers on how to create that ideal environment for BI on Hadoop architecture. Josh?
Hey, thanks, Irina, and thanks everybody for joining today. What I wanted to share kind of to get things started is a set of what I'll refer to as modern data architecture principles. And this is really based on some of the things that I've seen as I've worked with customers who are really trying to think about not just how do they do BI on Hadoop, but how do they leverage Hadoop as a way to start the journey to a modern data architecture for their enterprise. The first one is really viewing data as a shared data asset. I think in some ways this is nothing new with the advent of the data warehouse and enterprise data warehouse. Companies have gone down the path of trying to create a central data store. What Hadoop enables is really looking at that data store at much greater scale, collecting sensor data or customer data or clickstream data or security data And I think really starting with this mindset that, that tries to architect your organization as well as your underlying technology to treat data as a shared data asset for multiple consumers. If you're a large organization, you also have multiple lines of business or multiple companies that you may have acquired. Starting with that mindset of treat data as a shared data asset is really the first place to start. Once you've done that, the next thing is to really focus on providing the right consumption interfaces. And this has really been one of the challenges with traditional technologies and enterprise data warehouse architectures, is you end up really with this hub and spoke model where even though the data may be starting in one place, to meet different consumption patterns, frequency of use, response times, data latency, different data silos emerge. And what this means is that you have different platforms that are being used for different modes of data consumption. And this introduces all kinds of challenges into your architecture. As you'll see today, when Scott walks through kind of the ideal architecture from a Hadoop perspective, Hadoop provides multiple consumption interfaces for different workloads. It really is a mixed workload environment and enables you to both have shared data assets as well as different consumers on top of that same data asset. The other thing that Hadoop has enabled and this view of data as a shared data asset really requires is you really need to make sure you have security policies and access controls and encryption directly on the raw data. Now that you've got a platform that allows you to store all of your enterprise data in one place, focusing on security is top of mind for virtually any enterprise that we work with. So instead of having security policies that propagate out to the application layer or multiple data interfaces, it's really moving that data layer all the way down and sticking it right on top of your raw data. The fourth thing is, and again, this is nothing new, this is a concept of traditional enterprise data warehousing, is ensuring you have a common vocabulary. Now, there are all kinds of great benefits to having data in one place and providing the right consumption interfaces, but if different consumers are defining what is semantically the same thing differently, you've got all kinds of problems. A simple example of this is in the retail space, the fiscal calendar, that dimension and that hierarchy in defining what a week represents and which are the holidays, what was 2 days before Thanksgiving, those vocabulary elements are of critical importance. And if different data consumers are defining those hierarchies differently, what you end up is you spend all of your time explaining why two different data consumers report on what should be the same number in a different way. A fifth thing here is really, again, although there's value in having this data asset, if you don't have the right level of data stewardship, you run the risk of data consumers really not understanding the data that they're consuming. So data stewardship, you can do this as a data modeler, an enterprise data architect, the development of conformed dimensions and measures. All of these things are really important for your modern data architecture. And then the final thing, and this is really something that is near and dear to our heart here at AtScale, and what we see as a shared principle among a lot of the companies that we're working with, is at the end of the day, moving data and copying data is something you don't want to do. It introduces all kinds of challenges in the data consumption pipeline. It increases data latency, it increases storage costs, it increases processing costs. It really creates challenges from a maintenance perspective because you have different systems storing different amounts of data. So if you're able to eliminate those data copies and eliminate data movement on a shared data platform with a shared data asset, then you're really in good shape. So these are really some things to think about as you're embarking on your enterprise data architecture and you're trying to do so with big data technologies like Hadoop. These are some principles that can sit in the background, and as you're making decisions, you should think about, are we satisfying these principles for my modern data architecture?
Excellent. Thanks for setting that foundation, Josh. Scott, now that Josh has shared that baseline, how about we take the next step and share some details with our audience?
Sounds great, Irina. Thank you. So as we look at data lakes and data lakes potentially on Hadoop as central to the modern data architecture, I think a lot of what Josh mentioned really resonates. Organizations, the same business drivers that are driving new modern data architectures are the same ones that drove us towards the enterprise data warehouse and business intelligence tools 25 plus years ago. Organizations want to treat data as a shared asset, as Josh mentioned, and they want to do this so that they can create competitive advantage. They want to be able to reduce costs. They want to increase revenue. They want to mitigate risks within their organization, and they want to make better business decisions overall. But as they look to do that today, they realize that they have to take advantage of not only their on-premise data, which was traditionally structural relational database type of information, and expand that with social media data, click-through data, machine data. Josh mentioned several others. And how do you take this deluge of information that increases the volume and variety and turns it into something that can be useful for many different people throughout the organization? And that's really where the data lake comes into play, where on top of Hadoop as a distributed platform, you can increase the agility of the types of data you're processing. So you don't need to just process structured information. You can have unstructured data, and you can process the data in the raw format that it exists. So it gives you a more agile way to deal with data. There's lots of different tooling that you can use now to gain insights, whether it be data science notebooks, whether it be data visualization tools. You can look at this information and slice it and dice it more easily than you could in a traditional data platform, which maybe was more structured and you had to model the data before you could query it and those types of things. And then lastly, and probably most importantly, is using the distributed architecture to scale in a cost-effective manner. So these are all things that I think are critical as we look at data lakes serving as the central foundation to the modern data architecture. So if we look at that promise of what it provides, we can accept all different types of data, as I mentioned. You can store data in its raw format and then change it to formats that maybe are more performant or allow you to exchange the data in different ways as needed. And there's a whole host of tools in the ecosystem that let you look at this data and slice it and dice it in different ways. And ultimately, as Josh mentioned, you're trying to create this data platform that provides democratized access to data across the entire enterprise. So it sounds great. I'll take two. But in reality, if you look at the challenges that introduces, it's not as easy as it seems, right? Organizations think, okay, I'm going to create a sandbox environment with Hadoop. I'm going to load data into it. I'm going to prove some value and be off and running. But often what we see at Zaloni, where we work with customers as a trusted advisor as they head down their data lake journey, just building the infrastructure for the platform can take a lot of doing and a lot of understanding. And the rate of change in the Hadoop ecosystem in particular is so constant that it makes it difficult for them to know, which version should they take, which types of tooling under the cover should they use. And then ultimately that's creating a skills gap where, in the traditional data platform, it was maybe heavily SQL driven. Maybe organizations were using some types of BI tooling and those types of things. So you had this build up skills representation over a multi-decade period, and now you're asking these same folks to understand things like MapReduce, like Hive, like Scoop, Oozie, Spark, and other types of components within this ecosystem, and it makes it more difficult for them to take what they had before and use it in the same manner. Also, we're seeing complexity in the different types of environments that organizations want to set up. So the traditional data warehousing platform was probably set up in all on-premise within your firewalls and protected data, and now we're seeing Hadoop ecosystems where maybe some of it's on-premise and then maybe you burst into the cloud to expand processing and expand your cluster for certain periods of the month or the year and then bring those things back down. And how do you manage the metadata and the security of the information as you're doing that? Causes more complexities than what people had seen before. But that's getting better. Organizations are starting to better understand that. The distributions are maturing. They're changing less. But the next part of it is, how do I hydrate the lake? How do I get data into it? How do I manage ingestion for all different types of data? As the data comes in, we can't lose visibility of where it came from, who has ownership of the data, who should have access to the data, and is there data that should be secured and privatized as that raw information comes into the data lake. And I would say this is the number one thing we see at Zaloni that prevents the data lake and these newer architectures moving from beyond maybe a sandbox environment where very few people have access to it to something that's the true enterprise platform. And Irina, I think that the polling questions kind of showed that for the people that weighed in, where when we look at the nodes, the size of the clusters, most of them I think were in that 0 to 50 range, and there were very few customers that had 500 plus nodes. which would mean you're probably still in that departmental deployment for a lot of these implementations. And then lastly, you want to be able to deliver value across the enterprise. So you want to make sure you're providing high quality information. It's the same issue of garbage in, garbage out that we had with the enterprise data warehouse. We want to reduce the reliance on IT so that we can get access to new data sources without overtaxing the IT staff. And ultimately, you want this to be a reusable process that can be operationalized. IT wants tight controls over what happens, how often data is updated, and we need to be able to support that as well. So those are the concerns, but the good news is that we have a path forward. Right? At Zaloni, we work with our customers on a deliberate journey on the data lake where we focus initially on enabling all the data in your organization in the data lake itself. So that could be streaming information, that could be sensor-based data, that could be relational data, click-through information. Having a managed plan or a single place to manage that ingestion is really important. What's even more important is to be able to provide an organized catalog of this information where you can capture operational, technical, and business metadata that is then easily searchable by anyone in the organization so that they can see what data is in my lake, which percentage of the lake is being filled by information coming from Oracle schemas, what information is being filled by data coming from software as a service applications, and being able to be dashboards that can help you discern that type of information. Once it's there, you want to be able to govern it. You want to be able to cleanse it according to reusable data quality rules, both at the file or table and field level that can be reused across many of your assets in the data lake. You want to secure who has access to what, and this could be taking advantage of the underlying Hadoop ecosystem security, but also adding above and beyond that so that you can really control who has access to what artifacts in the data lake. And I already mentioned operationalizing it so that if the data changes or gets updated, how are you managing that process for data that's coming in from all different parts of the organization. And then lastly, we want to be able to engage the business. How do we engage as many end users as possible with tooling that they're familiar with to discover these data sets, further enrich them, and provision them and make them accessible to other existing BI or analytic tooling. And I think Josh will focus on that in his part of the presentation. So if we drill into the architecture a little bit more of what a complete data pipeline looks like, we'll focus on ingestion. I think as you're looking to go down this journey, and certainly at Zaloni with our Bedrock data management platform, you want to be able to have a single way to manage your ingestions. It doesn't really matter where the data is coming from, whether it's streaming, whether it's relational, whether it's log files, click-through data. One way to manage up what an ingestion is, where the data is supposed to go, visibility of who's ingesting it, why they're ingesting it, and capturing some of that core operational metadata is really important. If the ingestions get scheduled and are managed at scale to bring data in as fast as possible, then you want to be able to organize that information. And from my perspective, I think in my past background in dealing with data quality, data integration, and enterprise data warehousing tools, whoever has the best metadata wins. We look at, from an organization perspective, a single place to view both operational metadata, where the data came from, how often it should be updated, the technical metadata around the fields, the files fields, and other information that describes the data is important. And then the business metadata. Why was this data ingested? Who has access to it? Who owns it from a business perspective? Is it linked to any of our common vocabularies, as Josh mentioned? Being able to store and manage all of that then allows you to search this rich metadata of information in your data lake, not just by the HDFS or information in the H catalog, but by information that helps you as a business user determine the types of data you're interested in looking at. And it's also important to be able to set up and configure the privacy of the information and how often the data needs to be changed, what change data capture rules need to be in place, and storing this in a central metadata repository is critical. And once we have it organized, we want to look at how we can enrich that data. You're going to want to look for tooling that can provide the typical types of drag and drop ways to orchestrate data transformation, how the data is going to be queried, the different types of joins you might want to make on that type of information. At Zaloni, we do a lot with watermarking and tokenizing data so that if you made changes as information moves from one zone to a next potentially in your data lake, if you want to get back to the last known good, we can watermark it and go back in time and rewind the changes that have been made in the past. And then ultimately what we want to do is engage the business. As I mentioned, the whole point of this is to be able to make better business decisions. So if the one concern I think individuals had when the data lake, especially on top of Hadoop, was first provided, was the complexity of the environment reduced the folks that had access to this information. And that's something that we're working very hard to engage this into more parts of the business, and something I think that the AtScale folks do a great job of as well. So I wanted to end quickly with a data lake reference architecture slide, and this is something that at Zaloni we work closely with our customers to help them understand how they want to architect their overall data lake, the information that's in it, and what are the important policies that they use to govern the data as it moves from one part of the data lake to another. And this is just a sample that we've used with a few of our customers, but you understand the concept then of how you can use metadata and policy management to define and describe the data lake in ways that allow you to make the most use of that information. So on the left-hand side, we see the various source systems coming in, and on the bottom, we see the different types of operations from a metadata and data quality perspective that we may be performing using Zaloni technology on top of it. But the key is breaking the data lake up into zones, and maybe there's policies that say data initially comes into a raw zone where the raw data is stored untouched or unfettered. And from there, you can define policies around who has access to that information, but also maybe that data then gets moved and filtered, tokenized, maybe there's some privacy concerns, and you want to apply some masking agents to data that's in there before it gets moved into what would be called a refined data set, which maybe has gotten rid of some of the extraneous information. It's a little more refined than the raw data, and maybe it's been converted into a Hadoop-friendly format like Parquet or Avro for performance reasons. And from there, it can get further refined and made available to different consumers of the information. But at each part of this architecture, we can have specific types of policies on who has access to what's the overall quality of the data have to be before it can be moved from one to another. And in some cases, it may not be physically moved. There may be logical changes to the data that represent it in the different zones. But ultimately, what we're trying to do here is prepare the data to be used most effectively and found most effectively by the business users who are going to consume it in their business intelligence and analytics applications. And I think that's where Josh is going to step in now and show you the rest.
All right. Thanks, Scott, and a great overview. I love this slide. I think it provides a really nice kind of starting point to look at kind of your journey to a data lake architecture. Folks on the phone, if you want to screenshot this and print it out, I think it's a good thing to have sitting on your desk. It's a really helpful tool. You know, this reminds me, I'm going to talk a lot about the access, that guy on the right-hand side of the screen here. This picture here reminds me a lot of what we created when we were at Yahoo. Dave Mariani, who's the CEO of AtScale, and I were responsible for essentially rolling out the data lake at Yahoo. And really, there are multiple consumers of the data lake. We talked about this shared data asset, and the consumers we had at Yahoo ranged from our targeting system, where we were giving them segmentation feeds. We fed information into real-time serving for ad targeting decisions. We sent feeds over to the Yahoo Lab guys who were building predictive models. But a large number of our consumers really were business intelligence analysts or data analysts. And that's, I don't want to paint a picture that says the only thing that you want to do with your data lake is BI, but I can tell you that that's one of the most common use cases that we see as customers are rolling out their data lake, is they're trying to answer this question of how do I make sure that my data lake architecture or my big data architecture is really engaging business users? How do I drive adoption of the data that's in that data lake, that shared data asset, so that all of my BI users out there, all of the folks that are using tools like Tableau or Excel, or maybe more advanced users like users who are coming from SaaS where Scott used to work, how do we provide the right level of access to the data that's in that data lake? And this really gets into the world, if you remember, one of those principles of the ideal big data architecture was really this one about data stewardship and data curation. And a really common approach to providing the right interface to those BI tools has traditionally been create some kind of a dimensional model. Sometimes it's referred to as a cube, but this concept of a denormalized dimensional view of underlying data is something that works really well for these BI tools, whether you're Excel and you're doing a pivot table, or you're Tableau or MicroStrategy or business objects, and you're looking at the world in terms of measures and dimensions. This really gives business users the freedom to access the data in a way that's safe, in a way that has shared common definitions. The way this is solved today is people suck data off the system What we do with AtScale is we really provide an interface that sits directly on top of that data lake as it's been designed, and provides an interface that works for those BI tools, but remains true to those architecture principles. It provides an interface that's secure, one that doesn't move data, one that delivers performance, and one that leverages common definitions across the data sets that are in there. We focus really on three main elements to deliver on that vision of the ideal data architecture. The first is focusing a lot on a design environment that's really built for a shared data asset. When all of your data is in one place, the process of building a dimensional model becomes really a team process, because you have multiple users, multiple business analysts or data architects all sharing that data asset. And so a collaborative experience is really important. It's also really important that you have semantic consistency. And you'll see in the demo that dimensions or objects that are built in AtScale are reusable. So that date dimension that I talked about before, that retail date dimension, becomes a reusable object so that every consumer on top of the shared data asset is getting the exact same definition. The other thing that's really important is making sure that the tools that are accessing this shared data asset are doing so in a way that is secure. We've invested a lot within AtScale to provide the right data interface, which in the world of BI is either one of two languages. It's SQL or MDX, multidimensional expression language. So we want to make sure we have the right interface for consumption. At the same time, we want to respect the security controls that have been implemented on top of that raw data. So we've invested a lot in both the right interfaces along with a secure way of accessing the data. And the final thing that has been really an area of innovation for us is solving the problem of how do you deliver performance for those business users without moving data off the cluster. The way Tableau performance is often solved today, for example, is that Tableau data extracts are created and data is moved off the cluster so that Tableau performance is good. The way that Excel connectivity is handled is that SQL Server analysis services cubes are built. The data it goes from big to small and is moved off the cluster. What we're doing with our adaptive cache is we're optimizing the performance of the data model. At the same time, we're keeping data on the cluster. So what we're going to do now is I'm actually going to toggle over. So I'm just going to walk through a quick product demo and talk about, at least from our experience, what we see our customers doing as a best practice around connecting their BI tools to data that's sitting in Hadoop. The way I'll do this is I will dive in and I'm going to build really quickly a cube. My cube will look like, when I'm done, it'll look kind of like this, a dimensional model. Again, we think a dimensional model ends up being a great way to look at data for BI purposes. This is a best practice that's been in the industry for a long time. And so to create my cube, I'm going to start. Let's add a new cube here. Let's create my Data Lake Analytics virtual cube. And I'm going to start with, the way I start my cube design process is I'm going to connect to my data lake. And as Scott was talking, as he walked through the architecture, the big data architecture, the data lake architecture, one of those endpoints is a set of refined tables. We see this as a common best practice, is moving data from its raw form into a form that's been optimized for consumption. That may include creating hive tables, doing some data cleansing, doing some enrichment of the data, whether it's with geographic information or session information. So I'm going to connect live to my refined zone here, and I'm going to start looking at my sales log information. So I can drag in my sales log information onto the canvas. And here we are just looking at a refined table that's sitting in that refined data zone of the Hadoop data warehouse. And so you see I've got some nice columns. Hadoop data may contain some semi-structured data, so I've got some semi-structured data in there. And what I want to create is an interface for a business user tool that ultimately has a bunch of measures and dimensions. That's how BI users like to consume data. That's really some things haven't changed in the world of BI, and that continues to be a best practice, is looking at the world in terms of a dimensional construct. So I can really quickly start building, for example, my sales amount measure. I can look at order quantity. Hadoop provides me the ability to do some nice algorithmic things. For example, I'm going to look at a distinct count estimate using a distinct count estimating algorithm that allows you to do distinct counts at scale. And so in the period of a few seconds here, I've created 3 measures. And if I go to my cube preview, what you'll see is there are 3 measures. I can look at customers, order quantity, and sales amount. But now I want to be able to slice and dice this data. For example, I might want to trend that data over time. So I'm going to go into my reusable object library. If you remember, one of these best practices was having a common vocabulary. And I already have a pre-built date dimension that's been defined by another user of the system. I can bring that onto my canvas, and I can really quickly wire that up and represent my order date key. We provide some really nice utilities in the application. Previewing data, looking at join qualities is something that's really important, so I can identify this looks like a good high-quality join, and I can create that relationship. My product catalog is also something that I want to make sure is consistent across all of my users, and so I can reuse, in this case, my product dimension. So let's go and wire up my product dimension. Now, a final thing I might want to do, if you remember, is I want to look at that. Maybe I want to look at product color. So I've got size, weight, style, and color all embedded into a small single field here as a map, but I want to explode that map at query time. One of the nice things that Hadoop allows you to do is this concept of schema-on-read. At query time, I'm going to assert a schema on that data, and what I'm going to say is I want to create a virtual column. I want to take color out of that set of key value pairs, and I want to express color as if it's a string, and I want to add that as a virtual column. I can now really quickly turn that into a dimension, and I can analyze my data by looking at my color dimension as well. So if I go look at my cube preview, you can see that in the period of around 3 minutes, I've created a pretty rich cube here. It's got data attributes, product attributes, a bunch of measures. All I've done so far is I've created a virtual concept. This is really one of the nice things that the Hadoop ecosystem allows you to do is, as I mentioned, the schema-on-read best practice allows you to create structure at query time. So I'm going to publish out this cube, and I'm going to now make it available for consumption by a tool like Tableau. And now I'm going to connect to Tableau using something called a Tableau data source. This is not a data extract. I'm not moving data off the cluster. I'm remaining true to that principle of not moving data. I'm just connecting directly to, through the AtScale virtual cube to the data that's sitting on my Hadoop cluster. You'll see that I'm being asked to log in, so I'm going to respect all of the security that's executed on the underlying cluster. And I now have, for consumption, something that looks like the model that I built within the AtScale design environment. I can start looking at a standard measure like sales amount, and I can analyze that based on product name. And in fact, if I want to, I can even break that down and look at that by color. So I'm now using my tool of choice. I'm using Tableau. I'm executing queries that are directly on the Hadoop cluster. I've done it without moving data off the cluster, and I'm doing it in a way that respects the underlying Hadoop security. Now, the other thing that we talked about in terms of these principles of an enterprise data architecture is supporting the interfaces and the consumption models that people want to use. Now, I have yet to come across an enterprise that has only one BI tool. Tableau is very common, MicroStrategy is very common, but maybe the most common BI tool out there is Microsoft Excel. And so when I was interacting with the cube there in Tableau, I was sending SQL queries through the AtScale virtual cube to my underlying Hadoop cluster. Now what I'm going to do is I'm going to connect using Tableau, and I'm going to connect and talk to the AtScale cube using MDX. I'm going to log in using the exact same security credentials that I logged in when I connected to the AtScale cube from Tableau. I'm going to go and select that data lake analytics cube, and I'm going to all of a sudden have a live pivot table experience within Tableau. So I can look at those exact same, within Excel, I can look at those exact same measures. I can break down order quantity by color. And here in the back end, I'm sending an MDX query to that exact same AtScale cube. And so I've got this shared data asset. This virtual cube has become a shared data asset that is consistent with those best practices of an enterprise data architecture, connecting directly to that refined data zone within your data lake. So that is essentially it. Hopefully that gives you a sense of how AtScale is consistent with the enterprise data architecture principles and allows you to engage and start accessing data that is sitting on your big data cluster.
Perfect. Thanks so much, Josh. Appreciate that, bringing everything to life, bringing what Scott had talked about and creating, really taking the steps to be deliberate about creating an environment for the data so that there's consistency and accuracy and the type of data is ready to be actually engaged and accessed by the users. I wanted to really quick share an example of a customer who has taken these approaches and actually have ended up on a really positive side. So we all know about Yellow Pages. We've heard of Yellow Pages. We probably utilized it at one time or another. Well, in the digital age, Yellow Pages had to go from this book to online. And with that digital transformation really made them have to look at the way that they did business differently. And in all of a sudden, search advertising wasn't just a matter of switching a page, it was a matter of being able to access this data. And the data grew, and Hadoop became, or big data became, the right way for them to be able to consume all the information from across their business. And yet the challenges that they ran into were some of the ones that Scott was talking about earlier with regard to quality or access and so forth. And so they had this big data cluster, and yet the adoption by the end users was limited because of the number of factors. The data wasn't in the right format. It wasn't ready to be engaged with. The performance came into question. And so by Yellow Pages taking a very deliberate approach about readying and architecting their data lake so that it was prepared and ready for their end users, they were able to go from an environment where Tableau users were creating their own extracts. They were avoiding the IT team to instead working with the IT team as a partnership, and now they're able to, using Tableau and Excel, as Josh had demonstrated, able to query over 50 billion rows with 100+ users having access to that, all whether they're in Excel or Tableau, getting a consistent answer. You know, no more data marts or loads, adhering to some of those principles that Josh shared earlier, and really driving more quality decisions, quality data, by utilizing that single semantic approach and really making sure that they've architected the data underneath. And as a result, they've increased not only the experience for their end users, able to search and find what they need faster, but they've been able to drive a better experience for their advertisers, getting more users. And as a result, Yellow Pages themselves are driving more success as well. And so that was just an example of bringing together all of the things that we've heard from Scott and Josh today, how you need to take that approach to make sure that your data lake is set up, no matter what type of data, is set up appropriately across each of the different phases, whether it's thinking about ingesting data, organizing it, enriching it, and then engaging users. And across this spectrum, if you take that approach at each phase, you can achieve an ideal architecture that will meet your needs across your big data. And for those of you who aren't able to stay throughout all of our Q&A, I wanted to share a couple of next steps. Depending on where you are in your journey, as I mentioned before, we have a BI on Hadoop cheat sheet, so 5 things that you can do. We also have an ebook from Zaloni with the URL here, a lot of great information that can help you even further with more detailed step-by-step approaches. Or if you're at a phase where you'd like to see a one-on-one demonstration and see how you can utilize any of these solutions, reach out to either AtScale or Zaloni at the URLs here. And so with that, what I'd like to do is thank Scott and Josh, and I'd like to go ahead and ask some of the questions that have been submitted. The question is, how large is the data set that you're demoing? But I think there's a broader answer there that you could probably address.
Yeah, so good question. So the data that I'm demoing is in fact running on a little tiny Hadoop cluster that's on my laptop, and it's got a few 100,000 records in it. But one of the things that AtScale does, and I didn't go into depth in this on the demo, is we build up what we call our adaptive cache, which is really a cache that can serve queries against billions or tens or hundreds of billions of rows of data with the latency that BI tool users expect, which is results coming back in a few seconds or less. So the biggest deployment we have to date from a customer perspective is a large telco provider where we're looking at close to 480 billion rows of data running on a 400 plus node Hadoop cluster, and they're experiencing the types of response times that you saw in my demo. The AtScale architecture has been built to take advantage of the scale-out data processing capabilities of Hadoop, and we really scale with your Hadoop cluster. So our customers really like that architecture. What it means is if they need to add more data or analyze more data, they need to scale their Hadoop cluster. They don't need to additionally scale the AtScale deployment.
Great. Thanks, Josh. This next one sort of looks like a crossover. I'm going to initially target Scott with this one, but it may be related to Josh as well. And it has to do with the metadata. So the question itself is, what type of metadata is captured in the data lake initially?
Sure. So I think that when you're initially ingesting data into the data lake, what you want to do is try and maximize the types of metadata that you can capture. And in some cases, as Josh mentioned, Hadoop is set up for a schema-on-read, so you don't necessarily need to capture all the columns that are in any particular file or piece of data that's coming in. But at bare minimum, you want to capture where the data came from, who ingested it, what was the reason that they ingested it, how often does it need to be updated, where does the file live, what's the external path, both where it came from and where it's going within the data lake. And then from there, you can expand some of the technical metadata on the file name, the field attributes within it, the data types, and you can expand those. And in most cases, you can extract some of that natively with the different series that support the different files that are coming into the data lake. So from our perspective at Zaloni, we always recommend you try and capture as much operational metadata, technical metadata, and then the business reason for why that data is coming into the lake as part of a strategy for making the most out of it once it's there.
Great. Thank you, Scott. Appreciate that. Another question it looks like was posed here has to do with security. How do you integrate with Hadoop security?
Oh yeah, great question, and this is probably this is the first, second, fourth, and fifth question we tend to get from our customers, really all around security. And we've put a lot of effort into making sure that AtScale works with secured Hadoop clusters, whether that's ensuring that we connect using Kerberos, integrating with Active Directory and LDAP, and then also doing things like delegated authorization to make sure that access controls that are set up in systems like Sentry or Ranger are respected by all of the queries that AtScale submits.
Super.
Yeah, and this is Scott. I would just echo, I think I agree. That's the top 5 questions we get in every engagement. And Kerberos integration and LDAP is kind of a table stakes, but as Josh mentioned, being able to integrate and do impersonation and pass through to things like Ranger and Sentry is really critical as more and more customers look to implement that. So I think it's absolutely critical.
Great. Thank you, Scott. And it looks like we have one more question here. Which BI tools have you come across that are better suited for real-time processing and provide visualization insights on unstructured data? So thank you, Raju, for submitting that one.
That's a good question. I think there's maybe 2 elements there. The first is really around architectures for streaming data, and then the other is really around visualization. And most of the customers that AtScale works with, we're working with some of the traditional enterprise visualization tools, be they Tableau, MicroStrategy, Cognos, or Excel, as I showed. I think there are some tools that have been optimized for really looking at streaming network data. That's not the sweet spot of where AtScale connects to, but Scott may have some additional thoughts on that.
Yeah, I'd be remiss if I didn't mention my former employee SAS and their visual analytics product is integrated with their streaming capability as well. So if you're looking at real-time capabilities, they have it built in within their BI platform, and the visualizations they can do there are pretty slick.
Excellent. Well, it looks like those are all the questions that have been submitted today, and it looks like from a timing perspective, we are right about there. So I want to go ahead and get to our last slide. Sorry, we forwarded over a couple things. Go ahead and thank everyone. Scott and Josh, thanks so much for your clarity in helping set the stage for how to create an ideal scenario, an ideal architecture for BI on Hadoop. Thank you to all of our attendees. And as I mentioned before, you will all receive a recorded or a version of today's presentation. We hope that you receive value from it, and we hope everyone has a great day. Thank you so much.